Hello and welcome to another video. In this video we're going to be doing the second problem of the Biweekly Contest 122, and it's find if array can be sorted. And so in this problem you're given a zero-indexed positive array of integers nums, and in one operation you can swap any two adjacent elements if they have the same number of set bits. You're allowed to do this operation any number of times including 0. So set bits basically just means the number of 1 bits in the number. So for example, if our number is like 8 is represented like this. So there's one set bit here, and so on. So in this first example, everything's already sorted. In the second example, they kind of tell you what to do, but let's actually go over this one in depth. So we have 8, 4, 2, 30, 15. Let's write those down. So 8, 4, 2, 30, 15. And so really what we want to do is we want to figure out how many set bits are there in each of these numbers first. And you can actually use a Python function to do that, or you can do this yourself. And basically it's pretty easy to do it yourself. Like let's say for 8 is like this. You just keep anding your number with a 1 to check if the last bit is a 1, and then you just keep shifting into the right until the number is 0. So in this case we would get 1. So let's kind of write these things down. So for 8 there's 1 set bit. For 4 there's 1 set bit. For 2 there's 1 set bit. For 30 we probably have to write it out because I'm not sure off the bat. So 30 has a 16-bit, it has an 8-bit, it has a 4-bit, I think, right? So let's see, 24, 20, yeah, I think it's like this. Yeah, I believe this should be fine, right? So 16, 8, 4, 2 is 30. Is that right? Can't count today, so 24, yeah, I think that's right, okay. So 30 has 4 bits. And finally, 15 has 4 bits. 15 has 4 bits. So 15 is just 1, 1, 1, 1. Right, so it has an 8, a 4, a 2, and a 1. So 15 has 4 bits on. And now there's two ways you can kind of do this once you know this. One thing you can do is you can do a bubble sort, and a bubble sort's really easy, and this will basically simulate this thing, right? So it says you can swap two things if they have the same number of set bits. So let's kind of walk through what a bubble sort is really quickly. Bubble sort is basically you just go through the array, and anytime there's an element that is bigger than an element after it, you just swap them. So let's kind of walk through that. So we go through the array, 8 and 4 should be swapped. So we check, do 8 and 4 have the same number of bits? Yes, they do, so we are allowed to swap those, so we'll have this. Then 8 and 2 should be swapped. Do 8 and 2 have the same number of bits? Yes. So we will swap those, right? So we'll have it like this, then we will swap, so it'll be like this, 4, 2, 8. Then 30, and then 15 should be swapped with 30, so do 15 and 30 have the same number of bits? Yes, they do, so we can swap those, so 15, 30. Okay, and then you basically keep doing this until your array is sorted. So you just write down, like, have I done any swaps? If you have, then you look through this array again. So let's look through it again. So 4 and 2 need to be swapped. Can we swap 4 and 2? Yes, we can. They have the same number of bits, so we have 2 and 4. And now, like, there's nothing else that needs to be swapped. So you said you did do a swap. Then you go through it one more time and you say, okay, it's all in order, so we're good. And that's basically how you do it. And then anytime there needs to be a swap and the number of bits are different, you can just have like a hash map or something. Then you know that you return false. So you essentially just perform bubble sort. Anytime some things need to get swapped and the number of set bits are different, then you return false. That's one way to do it, and this is going to be n squared. Bubble sort is n squared time complexity. Now there's another way to do it, and that's going to be O of n. So let's actually take the same example. Let's actually use example 3 maybe. So we have 3, 16, 8, 4, 2. We can go through both of them pretty quickly. So 3, 16, 8, 4, 2. So the other way to do this is actually, and they kind of show you this if you actually look at the hints for the problem, is you want to separate your array into chunks that are consecutive and have the same number of set bits. So fun. Okay. So basically you want to see how many set bits are in here, and we already have this information. So 3 has 2 set bits. Just know that off the bat. So we can actually write the number of set bits on top. So this is 2, this is 1, this is 1, 1, 1. So basically you will split your array into these two chunks. And you can actually do this like on the fly. You don't need to split it into two arrays. You can actually calculate this on the fly. right? So for every chunk you're traversing, you want to store two things. You want to store the minimum and the maximum. So for this chunk, you're going to be traversing and you're going to say, okay, the minimum is 3 and the maximum is 3. Then for the next chunk, you get its minimum. So for this chunk, the minimum is 2. And in a sorted array, the minimum of the chunk that comes after the one before has to be bigger or equal to than the maximum of the previous chunk, right? So because 2 is in this chunk, like every chunk, you can move all the items around, but you can't swap items between chunks because they have different numbers of set bits. So because 2 is the smallest number here, and 3 is the biggest number here, you're always gonna have 3 and then 2, right? You can't fix that situation. Like this 2 will never be sorted. So if this 2 wasn't here, then you can make it sorted because now the smallest number would be 4, and the biggest number would be 16, which would be totally fine, right? Because then it could be like 3 and then 4 and then so on. So basically for each chunk, you keep it a minimum and maximum. Once you get to the next chunk, you just check, is the minimum of my chunk now bigger or equal to the maximum of the previous chunk? And if it is, that means you can sort this. So let's actually go back to do this example, or it's actually just make an array. Actually, let's actually use this one because it's going to be hard to get an example that works. So let's use 8, 4, 2, 30, 15 to show this one more time. So 8, 4, 2, 30, 15. So if we go back to our previous dictionary here, so 30 has 4 and 15 has 4. So the chunks are going to be, these all have one set bit, so this will be one chunk, and this will be another chunk, right? These have one set bit, these have 4. So you kind of do the minimum and the maximum. So the minimum and the maximum here is 2 and 8. And then here the minimum is 15, and 15 is greater than or equal to 8, so this is fine. So you just keep traversing chunk by chunk, storing a local maximum of the chunk and the minimum of the chunk, and then once you go to the next chunk, so let's say you traverse this chunk, you have this stored, right? The minimum and the maximum. You're traversing this chunk, you have this stored. Then once you go to the next chunk, you say, okay, I'm done with this chunk. Now let me make sure that this criteria holds, right? Let me make sure that the minimum of this chunk that I traversed is greater than or equal to the maximum of this chunk. And if it is, now I don't need this chunk anymore. So now I'm just going to store this as like the previous min and max, and I'm going to have my current min and max over here. And that's kind of how you do that, and that will give you an O(n) runtime. So let's look at the code really quickly. That's pretty straightforward. So we basically just initialize our first chunk to be the first element. So we just say like the current max is num0, current min is num0, and we have a previous, right? So I just initialize a previous to be -infinity because then our current chunk will always be greater than that, right? And because the first number will always, like the first chunk will always be valid, so we can do that. And there's also a bit count method in Python that gives you the number of set bits for your element. So you can use that or you can write your own. Either one's fine. So you just loop, and then you just check if the current number is, you're storing for every chunk, you're storing this current bits, which is just the number of bits in your current chunk, right? So you're going through this chunk, you're saying, okay, the number of bits is 1 in here, and then when you get to this number 30, you say, oh, there's 40 in here, or there's 4 bits in here. So now this is a new chunk, and now my number of bits in the chunk is 4. That's basically what we're doing here. So this just means we have a new chunk. So if we have a new chunk, then we have to make sure that the current min is, let's see. Oh, right. So the current min has to be greater than or equal to the previous max for this to be true. But if the current min is less than the previous max, then this can't be sorted, right? And that's kind of like this problem here. So the previous max here would be 3, and then the current min here would be 2. If you did have this 2, and then this would never work. So that's pretty much what we're doing here. Otherwise, we just put in our new stuff, right? So the previous max is going to be the current max because we just finished with this chunk. We get the bits of the current chunk we're at, and we get the current min and the current max of the current chunk we're at, which is just the new chunk, which is just I. Otherwise, we just keep updating. So if we're still on the same chunk, then we just update the current max and the current min with the new number. And then finally, at the very end, you will have, so at the very end, you will be on some chunk, right? Because like you'll be on some chunk and then you'll run out of elements in the array. And then for whatever chunk you have, you just have to make sure that's valid. So for once you're done, you'll have some chunk and you have to make sure that the min of that chunk is greater than or equal to the max of the chunk before. And that's basically what we're doing here. So if the current min is greater than or equal to the previous max, that means this can be sorted. So that's how you do it in O(n) and 0 space. You don't really have to make an array or anything. You can just constantly keep track of the current chunk min-max and the previous chunk min-max. And as soon as you get to a new chunk, you can discard the one before, right? So let's say we're on this chunk, we will keep track of the current chunk min-max and the previous over here. And then once we get to a new chunk, we can discard all this information because that's no longer needed. And then we'll restore these two chunks and so on, right? So you just keep the info for the chunk you're on and the chunk right behind that. And yeah, that's basically it. And we can run it and it's pretty good. So let's see. It was beating 100. Yeah, so it's kind of like inconsistent, but basically this is like as fast as it gets. So the time here is going to be yeah, I guess, let's actually look at one more thing. So how big can these numbers be? So these numbers can be 2 to the 8th. So technically the bit count of a number is logarithmic. So maybe you should probably better off writing it's like n log n technically, because if all these numbers are big, to get the bit count of a number, what you're basically doing, like let's say your number is something like this, right? You're basically just checking the last bit and then getting rid of it, checking the last bit, getting rid of it, checking the last bit, getting rid of it, and so on, right? So that's logarithmic. So you can argue that this would be like n log n because getting the bit count of a number is logarithmic. Or you can just say like, you know, you can say it's O of 1 as well. Like, I think most people wrote that it's like O of 1, but in reality it's n log n. So maybe I'll just say it's n log n because yeah. And space is O of 1. Just these constant variables. No need to actually like store the chunks. Just store the relevant information, which is the min and the max. And yeah, it's gonna be all for this one. And then I will. Someone asked me to do like the later problems. I'll definitely get to those in the next coming days. And I'll do the problems for the weekly contest as well. I've just been kind of busy today. Like I think I talked about it before. I had a TikTok take home that was like 2 hours, and I had a bunch of other stuff, so I didn't want to do like 15 LeetCode problems in a day. So, but yeah, what's kind of interesting. So on the TikTok take home, it was like a LeetCode hard and 2 mediums, and I think I got 100% on it. So we'll see how that situation unveils. And yeah, if you did like this video, then please like it and please subscribe to the channel. And I'll see you in the next one. Thanks for watching.